Alright, good afternoon everyone here. Welcome to today's Sec 4 EMAth lesson on 2 p.m. with teacher Jason over here. So let's get the lesson started. Again, some general rules. Just make sure you're patient and understanding. Observe gracious and respectful behavior even when you're typing along. And lastly, along the lesson, ask good and relevant questions for the lesson for today. Alright, so as touched on, what are we learning for today? In fact, for the first few lessons, we are actually going to do a little recap. In this case, what are we recapping for the mean, median, and mode? And lastly, the whole lesson is actually going to be on standard deviation, what it means, and how do we calculate it along the way. So, let's do a little recap over here in this case of mean. Now, in this case, okay, to do a little recap, mean over here, how we calculate is like the average. So all these are the measures to calculate your data. So how to calculate mean is basically the sum of your data over the number of data values. All right, if you are unsure how do we do that in terms of math-wise, you will actually be able to see them as we go on the lesson by. Okay, sum of data over number of data values. That is your mean. Now, median over here, we are focusing, as the name suggests, median. It rhymes with middle, so the value of the data in the middle position. And make sure, very important, when you do the median, don't always assume that your data is arranged in the ascending order, all right? Always make sure that you check that your data is in the ascending order. Okay, next one, mode. Mode is what we call the result with the highest frequency. You realize we didn't really touch on it in the previous 3 weeks because this is actually touched on in your Sec 2. So basically, what is mode? Again, we will have data to back it up later on. Okay, now, next up, as I mentioned, how do we calculate mean? Is this formula over here? But how do we exactly calculate? Suppose, let's say you have the mean of this data set, and you were to recall just now, mean we represent it with a bar on top of the variable, usually denoted as x, or if x is used, we use y or z per se. So in this case, find the mean of the given data set. So you realize mean over here is a fraction. So let's test your, at the top, what do we do over here? All right, Chen Zheng, that's actually correct. That's the answer, but let's have the benefit of everyone. But doing good, Chen Zheng, doing good, doing good. For the rest, what do we do at the top of the denominator over here? All right, very good, Chen Zheng. Anybody else still wants to try? Okay, give it a shot. What do we do at the top of the denominator over here? Okay, let's think about it. Sum of all the data values. These are all my data values. So all I need to do is actually, very good, Alicia, very good, Denise. You just add up all the numbers. So 1 plus 7 plus 8 plus 16 plus 18. And over here is the number of data values. So there are 1, 2, 3, 4, 5. This is an instance whereby the frequency is not given to you, basically the number of data values, and you can count them easily. So in this case, it's going to be 5. And over here, 50 divided by 5, just sum them all up. And afterwards, you get 10. So this is how we calculate the mean, very straightforward. And in this case, you realize, is there a particular shortcut that's available in the calculator? Stay tuned as we go along the lesson. You will find out accordingly. Now, next up, why do we learn standard deviation? What's the purpose of standard deviation? So let's investigate and find out, what is the purpose of standard deviation, and truly said investigation. So let's calculate for this data set first. Okay, now if you were to find out total frequency, just count the data sets. 1, 2, 3, 4, 5, 6. 6 data values, therefore total frequency is going to be 6. Mean over here, as we recap, just add them all up. 2 plus 3 plus 3 plus 3 plus 3 plus 4 over, in this case, 6 data values, which is 3. Okay, now median is the middle data. Can anybody tell me what the median is over here? What is my median? Very good, Isabel. Very good, Chen Zheng. Perfect over here. Anybody else wants to try to have a recap? Correct. Okay, the position is correct, Denise, but I want the number. What is the median number? Very good, Denise. That is exactly right. Anybody else still wants to give it a shot? Very good, Singy. Perfect over here. I think you guys are getting the gist. Doing good. Let's carry on the flow. So you realize median is basically the data that cuts the data set into two. Okay, so in this case, there's no need to rearrange, but take note, always refer to the question to check that whether there's a need to rearrange in the ascending order. And in this case, it's in the 3.5 position. So we are taking the median of the third and fourth, we divide by 2. This is my median. Lastly, the mode. Okay, this wasn't really gone through in the previous 3 lessons, but let's try. What is the mode for this particular data set? In this case, very good, Denise. Isabel, perfect over here. Anybody else who wants to give it a try? Very good, Alicia. Awesome, Chen Chen. Perfect over here. You guys are very, very hyper today. Right? So because the mode is the data value that appears the most, so in this case, 3 appears the most, 4 of them. So that's why in this case, my mode is 3. Interquartile range. Now let's recap interquartile range. How do we calculate the interquartile range? And in this case, maybe it's a little bit hard for you all to type, so let me rephrase my questions. Very good, Denise, but in this case, to do your working, what is the interquartile range I have over here? That is the working, correct, Denise, but which I'll share to everyone later. Very good, Alicia, perfect. Anybody else still wants to try? Anybody else wants to give it a shot? Okay, so let's recap. Interquartile range is your upper quartile minus lower quartile. So we're essentially finding the medians of the upper half of the data set. If you refer to my slides, upper half of my data set. This is the median for the upper half. This is the median for the lower half. So therefore, upper quartile minus lower quartile, 3 minus 3 is equals to 0. Now, this is the data set. Take note, 63330. Emphasize on that. Let's look at a totally different data set. Okay, in fact, yeah, it's a totally different data set and see. Total frequency here 2. Okay, I'm not going to bore you all. Mean, just add them all up. 0 plus 3 plus 3 plus 3 plus 3 plus 6 over, sorry for that, it's not very nice, 9 over 6. This is going to be 3. Okay, carrying on my median, you realize it's going to be the same, 3.5 position. Okay, then my value is not 3.5. I'm saying the 3.5 position, which is just 3 plus 3 over 2, which is 3. Mode here, as you all can see, is 3 as well. Interquartile range, this is my upper quartile, lower quartile. So therefore, I have 3 minus 3 is equals to 0. Now you realize over here, the data set are obviously different, but everything else is the same. What can we say about this? And in this case specifically, we realize IQR for both is equals to 0. Based on what you have learned in the previous lesson, we talk about IQR. The lower the IQR, the more consistent the data. And in this case, since both of them are the same, they are equally consistent. But are they really the case? Not really, right? The data set are definitely different. They are not equally consistent. So therefore, it is not the case, and henceforth, we need another measures for spread, which is why you all learn standard deviation. Okay, so for the next few slides, we are going to talk about standard deviation, and after that, we are going to come back to this investigation and find out which data set is actually more consistent. Or actually, by eyeball, I believe you all know which data set is more consistent, but let's bring it up and hone ourselves to the concept of standard deviation, and later we bring it down towards this investigation again. So you're going to see this data set again, but at the end of the lesson. Okay, so now let's take a look at what it means as a standard deviation. What does it mean for the standard deviation? Now, if you were to recap, okay, before I write down the definition here, does anybody know what word do I fill in here to measure, to understand this definition? Overall spread of the data. What is this word over here that I take note? Good try, Denise, but this is overall spread. Okay, I'm looking at all the data, not just the middle data. Okay, in fact, IQR is part of it. Okay, I'm looking at all the data. IQR focuses on the lower quartile and upper quartile, in fact, the middle one. Alicia, okay, good try, Chen Zheng, good try, Alicia. Median we went through already is not median, it's a value. It doesn't measure a spread. Okay, frequency over here measures a Number of data set, what's the total data set? Over here, we're talking about spread. We are talking about median and mean. Don't try to bomb everything, Denise. I know you're trying your best. Median and mean is the averages. Over here, we're talking about the spread. So realize overall spread, right? Suppose this is your data set. Okay. Lowest value here, highest value here. I think you all get the hint already. Lowest value here, highest value here. Okay, sorry. Lowest, highest, yes. Okay. We're talking about how spread out all the data set, including the lowest and highest value are. So we are talking in this case, the range that measures the overall spread because it focuses on the lowest value and the highest value. Now, if we then focus on the middle data, because sometimes the range is not very accurate because it can be very far values such that it's too far away from the middle set of data, the enclosed set that we are looking at. Okay. We look at this thing called the, Denise has mentioned before, interquartile range. Okay, so just to recap, range is the overall spread. Now, but then if you want to look at all the data set, we just want to look at in the middle. That's what we call the interquartile range. Okay, so the definitions again is more for you all to understand what matters most important. That range being highest minus lowest is more important to measure, and interquartile range being upper quartile or the 75th percentile minus the lower quartile, which is 25th percentile, it's more important in terms of calculating them. Okay, the notion of calculating them is actually sort of more important. First, before we talk about the consistency, range being not so accurate, interquartile range more accurate, and lastly, standard deviation. Okay, again, it measures the spread of data, but what does it measure? In fact, Chen Zheng and Denise have actually mentioned this particular word over here. We call this word mean, and it measures the spread of data, but we measure how far it is away to the mean. And how do we illustrate this particular notion into a formula? Okay, so there are two types of formulas. Now, when I go through this, please either write down the formulas, or if you want, take a screenshot, because we are going to use these formulas very, very often. So there are two ways. One, you take a screenshot, or two, you can write down the formulas. And of course, I'll explain to you what they mean. Now, relative to the mean, you realize over here, the minus sign actually demonstrates how far they are away from the mean. And we take the square because sometimes the value can be below the mean. Henceforth, we want to make sure that there are no negative values, all positive. So that's where we talk about squaring the mean. So we talk about the distance away from the mean. Okay, so how do we interpret this? This one over here is what we call the sum of the data values. Sum of all the data. Okay, and over here, this is the mean that you are looking at. Okay, and over here, my n is just the number of data sets. How do we actually utilize this? Stay tuned, we'll find out with an example, so don't worry about it. Now, you realize what's the difference between for without frequency and with frequency? Is that with frequency, there's a notion of f over here. Okay, so again, the notion is similar, just that. Okay, we're looking at sum of all the data sets whereby my square of the values corresponds with the frequency. And just take note of the keywords here. When I go through examples, it will definitely be much more clearer. All right. So just take note of the keywords here that I mentioned. So squares with the respective frequency. And over here, we are looking at the number of data sets. Number of data sets. And in this case, the mean over here is what we're looking for. So why do I emphasize this formula even though I said, or even though that you can use your calculator? Because for standard deviation questions in particular, there are some values whereby the questions wants you to show. Basically, the particular things that I have circled. The mean, the sum of squares, and the number of data sets. These three things are what they want you to put in. Okay, so these are actually my key values. for you to put in the work. Alright, so again, just take note, if you forget what I say, just make sure you take a screenshot or make sure you have the formulas there, because we are going to refer quite a lot in terms of the formulas. Alright, so now let's bring on to a work example to sort of understand what I'm talking about over here. Alright, okay, so referring to the formulas that we have, calculate the mean and standard deviation. Alright, first one, the mean. If we talk about the mean, again, it's just adding 5 plus 3 plus 8 plus 10 plus 4. Again, the number of data sets is 5. Okay, summing them 30 over 5, this is going to give you 6. All right, not an issue. This is the recap. Now, standard deviation. Now, let me write down the formula for you to recap first. Standard deviation, again, classified I write here as SD. It's going to be square root of my formulas over here. So sum of x squared over n minus the square of the mean. Now, before I carry on, does anybody want to give it a shot? For in this case, okay, this one is not an issue. This one is not an issue as well. But I want you guys to think about it. No need to solve for me, but give me the expression, or if you guys are actually enthusiastic enough, you can give me the answer for this. But mainly, how do I write this out given this data set? Okay, I'll give you some time to think about it, write it down. How do I write this given this data set over here? Because sometimes think about it, because the expression is rather long. Okay, so it's the sum of the squares of the value I'm looking at. So how do I write it down? All right, let me take a look. All right, that is actually correct, Denise. Very good. All right, that is actually correct. But anybody else wants to try? It's a little long expression, so that's why I'm giving you all a little longer to sort of type it down. So don't worry, don't rush. I'm giving you all some time to think about it and write it down. Okay, well, good job, Denise. You are getting the hang of this. All right, keep it up, keep it up. So for the rest, give it a try, write it out. What does it mean for, again, the hint is my expression is very long. Number of data sets, I'm not going to write it down, 5. Mean is what we've calculated, 6 square. Again, I'll give you some time to write it down. What will be the expression I'm looking for? It's going to take a while. Right, I'm waiting for the responses. Okay, I'm seeing them pouring in. Let's see, I might not. Okay, all right, very good. All right, so you realize what happens over here. Sum of x squares. What we are doing, we are literally taking the squares of each of the values and summing them. Okay, so taking all this, what we do, this is what we need to do, and afterwards, we sort of evaluate the top and bottom, even though the bottom is given already, so it's going to be this way. And lastly, over here, just take your calculator, press it, find the answer, truncate my value first. Remember, truncate in terms of phi SF. You can take your calculator and try. You're going to get 260768. Round off, remember, round off to 3 significant figures, or 2 decimal places. 3 significant figures. Yes. So this is your way of calculating standard deviation. And remember, when I say the key values, when you do the standard deviation question, you will only need to show these 3 values. This one, and this one. Making sure that, of course, you don't calculate this wrongly. Alright, so just make sure when you do your working, it's just going to be standard deviation equals to this one, 1 mark, equals to calculating it correctly. That's your 2 marks for standard deviation. Alright, but in this case, if you want to write this down to make sure you can refer to them properly, it's okay. I'm leaving it to you. Alright, any queries so far before I actually let you all try to, before I go on? Sorry for that. Alright, now you may wonder, is there a particular shortcut that I can look for in the calculator instead of just calculating it by hand? Now, in fact, good thing is there is, but what happens is there are a lot of calculators over there, the calculator videos that I'm going to show later on, to sort of show this shortcut may not be the calculator that you are looking for, but see the relevance and see how it actually sorts of help you calculate. So what are the different interfaces that you see in the calculator to make sure you can calculate the value. All right, so let's take a look. First one, how do we calculate the calculator input for, in this case, this particular calculator, Sharp? Okay, so for those who are using a Sharp calculator, take note. For those who are not, don't worry. Just make sure to see what is available there. Okay, now, first, what happens? Okay, you toggle yourself to the stats mode first. So you click a few buttons. In this case, firstly, you click the mode button, click the stats button, and after that, standard deviation. First part, make sure you are in stats mode for the Sharp calculator, and you see this. Okay, for those who are not using Sharp, it's okay. Just make sure that you understand what is going on. In this case, first step, step 2, stats mode. Next up, what you do, you key in the data values from the previous one. Again, recap: 5, 3, 8, 10, 4. So you go back. Okay. Key that 5. Key in the M plus button. There's an M plus button over here. All right, M plus button. M plus means to add the data value. So carrying on. Okay, so just let the video run. 8. Again, so you see there are 3 data, 4, and lastly 5. Okay, once you're done, okay, now we want to calculate. So how do we calculate? Okay, you realize I've done a few things over here. Rewind. Okay, you realize I've done a few things. I want to calculate. So what I do, there are specific things to help me calculate. So let me just close this. Okay, I need to toggle this alpha button. Why so? Because you realize at the few things over here, the key values to calculate are in the calculator. So if I want to calculate the mean, you realize is at the button 4. This is the mean. For those who cannot see, this is the mean. Okay, number of data sets. In fact, you can calculate that as well if you are fearing that you cannot count. And lastly, the sum of the squares. Okay, so I'll let the video do the talking. So let me just toggle it down. So 4. Okay, the mean is 6 as we calculated. Again, going there. Sum of squares 214 as we calculated. And 5. Okay, so what you have, once you have all these values, you put in the working, and you can double check the standard deviation as well at the last part, which in this case it's this one. Okay, it's a bit blur, but the standard deviation is over here. That's the last part. And therefore, you are going to go to what we've calculated, 2.61. Okay, so that is the notion for Sharp calculator. I hope that this gives a clearer notion of how to calculate it without frequency. That means there's no frequency given. Okay, now for Casio calculator, how does it look like? In this case, similar notion, but what are the steps? First things first, you set to the stats mode. Always remember, your calculator is not calculating, but now it has to go to the stats mode. So how do we do it? Okay, first, you set the stats mode. So this one a bit complicated. You have to click the shift button in order to go to the shift button, and then you click the menu button. Then after that, you go to the stats button by clicking 2. And of course, on the frequency, easier for you. Now, after that, what you need to do next is key in the data values. This one a bit straightforward. Again, from here, what you do, you click the menu button. Okay, go to statistics. It's the one with the bars over here. Then after that, what you do, okay, one variable, and after that, you just toggle with the arrows. So toggle the arrows up and down to key in 8, 10, and 4. Okay, it's just to toggle between the arrows to get to the interface. And what you need to do, next up, click the AC button. Make sure you revert back to the main screen so that you are clear. Before that, make sure your data values are correct. After that, what you do, this calculator allows you to calculate everything. So what you need to do, click Option. And over here, you see this thing over here, one variable calculate. That means it calculates everything for you. And you realize all my values are here. There's 6, there is 214. Data values, you have to scroll down a little bit. Okay, just scroll down with the arrow keys over here, but you realize my standard deviation is here. All right, so this is for Sharp and Casio. Okay, I understand that some of you may not be using that, but you realize the main things over here when we do for calculator. Set to stats mode, key in data values, And after that, find the crucial values for you to put in the working. In this case, 3 values to take note. Okay, let me revert back to the concept. One is the sum of squares, the other one number of data sets, last one is the mean. These 3 have to show in the working. All right, now to get you all to understand a little bit more, let's get on to the first bubble question. Okay, quite straightforward. Find the mean of this data set. Let's see how it goes. Don't worry, you don't have to follow the shortcuts above. If you're unsure, you can always do it manually with the formulas that you screenshotted just now. All right, launching the bubble, 1 minute in 3, 2, 1. Let's go. All right, awesome, doing good. Okay, so how do you calculate the mean? And making sure you don't get the wrong values to put in. All right, doing good. Doing good. You have the last 30 seconds. All right, doing good, doing so well. Perfect, perfect. I'm seeing very good responses here. Take note, how many values do I have? Okay, last 20 seconds. Counting down to my last 10, there are still a few of you yet to answer, so just answer it accordingly. 4, 3, 2, 1. All right, most of you got it right. That's good, that's good. I'll just go through. Okay, so in this case, mean, if you can just use your calculator for the shortcuts. Or if you want, what happens is 14 plus 30 plus 23 plus 28 plus 16. Divide by how many values I have? This is going to be 5. So therefore, 111 divided by 5, this is going to give me 22.2. This is then my answer over here. Okay, some of you actually answered 18.5 because you have calculated wrongly. You divide by 6 instead. Take note, there are 5 values, so the number of values over here is very important. Okay, now, I believe you know what's coming up. If I ask you all to find the mean, definitely I will ask you all to find the standard deviation. So this is going to take a little bit longer, so that's why it's 1 minute and 30 seconds. For those who know the shortcut, it will be faster. But for those who have not, it's all right. Okay, take note, I don't expect you all to memorize the mean. I'm going to write down for you. The mean of the data is this. Calculate my standard deviation. All right, counting down for your 1 minute 30 seconds. 3, 2, 1. Let's go. Take your time. Please do not rush. Okay. All right, perfect. That's nice. That's nice to see. Okay. So just remember, number of data values, mean, which is what I've given you, which is what we have solved for before, and the sum of the squares. All right, doing good. I'm liking your responses over here. So if you realize standard deviation can write as SD, or in fact, this is a universal recognition of the standard deviation symbol. All right, 15 more seconds for those who have yet to key in as such. Or in fact, you have your calculator. You can calculate the sum of the squares with your calculator. I've given you a hint already. Sum of the squares is involved. Some of you all forget to make the mistake. Take note, you all key in a value, but you all forget to key in something very important. All right, counting down to my last 20 seconds, I would say. Okay, remember, for the square root sign, it's going to be a very long square root over here. Okay, counting down to my last 8 seconds, I would say. All right, okay, never mind. It's okay. I'll ask this question later. Counting down to my last 2. Okay, seems like there's some mistakes that I'll make over here. So let's see. Okay, not too bad. Most of you got the answers down, but let me just go through to see what went wrong. So some of you, I realize you'll choose number 4 or number 3 because one, if you were to use the calculator, you might have clicked something wrongly. Okay, remember when you click the calculator, you should look for this symbol. Okay, in the calculator, what happens is there's this thing called SX. Okay, don't use this. Use this symbol. All right. Okay, now, next up. Always remember standard deviation, remember your square root. So in this case, sum of the squares, 14 square plus 30 square plus 23 square. Take note, you may wonder, teacher already say, no need to write this. Why am I still writing this? Again, it's for the thought process for this lesson. So divide by 5 minus the mean square, 22.2 square. Use your calculator, all right? The data values to show, very important. Understand that your answers get correct. But again, the values to show, it's going to be the top 2665 divided by 5 minus 492.84. When you show your working, when the standard deviation question is 2 marks, remember these values over here. You have to show 2665, 5, and 492.84. Okay, so very good question, Denise. I'm going to bring this question to all because why is it this way? Okay, why they don't just write this and write this? Okay, because what happens, you are doing this for one variable. In later terms, when you do for two variables, which I'm not going to enforce because you're not going to touch it forever in your Sec 4 education, okay, but in this case, why they do for x? Because if they do for two variables, they need to define the standard deviation for each variable. So that's why they write for sigma, we call it sigma, of this variable x. All right, but that's a good question. That's why you realize there's a sigma x at the bottom, which I've written just right there at the top of the slide, top corner. I can't really stretch it through because my finger will get cut, but at the top corner of the slide. Yeah. Okay, so I hope you that understanding it's there already. Okay, so that's the notion why they write an x below. Now to simplify further for you, I'm gonna get this value. Remember, typing a calculator with the square root. Again, truncate, you're gonna get 633,719. Round off 3SF, you're gonna get 634. Again, this is for 3SF, and therefore this is our answer. Okay, so just remember the square roots and the notion here. Okay, so why the calculator write as sigma x? Because you're calculating for one data set. In higher level math terms, sometimes we need to calculate for two different data sets. And each data set determines a different variable, x, y, z. In this case, this variable, I define it for x. Some other data set, they define it as y. So to sort of segregate them differently. Okay, in short. Okay, so I hope you get my explanation, but if you're not sure, it is okay. After, yes, so it's just for understanding, so don't worry about it. Okay, all right, so let's move on. So first part, you realize we focus on without frequency. But now what happens if there's frequency involved and in this case, ungrouped data? Basically, your data set is still singular, it's not in a group. Okay, again, the mean formula stays the same, but the things to fill out at the top and the bottom is going to be a bit different. For the top, what do we fill in? Or in this case, if you feel the expression is too long, hint, what is the value at the top? All right, so I'll give you all some time. What do we fill in at the top over here? Or what is the value at the top? Choose to answer one of them. All right, don't worry about it. So what's the value at the top? Or if you guys are ambitious enough, very good, some more values certain, but what? Okay, then maybe I enforce a bit more. What is the value at the top for this data set? Give me some time to think about it. Some of the values, yes, but what do we sum? How do we sum? That's the hint over here. How do we sum? Okay, or in fact, what's the value over there? If you're sometime understand the expression is a little hard, little tedious. Yes, that's right, Denise, that's the answer. Perfect. Some of you, if you want to give me the answer straight, also can. But that's the answer. Very good job, Denise. Okay, but I'll give you all some time. Maybe you all are still a bit rusty over here, so I'll give you all some time. All right, okay, I think I see some responses. So realize, how do we calculate this? I hope you all recall. This tells us what? Interpret. There are 2 1s, 6 2s, 8 3s, and so on for this data set. So to calculate the total sum of values is going to be 1 times 2 plus 2 times 6 plus 3 times 8 plus 4 times 3 plus 5 times 1. Okay, now at the bottom, what do we sum? Take note. Let me label for you. I call this whole row A, I call this whole row B. For the bottom, do I sum the whole row A or whole row B? Write down your responses, A or B. Let me know. A or B, very simple. A or B. What do we sum? Do we sum the whole row A or sum the whole row B? Alright, that's good. Chen Zheng, that's the answer. Anybody else still wants to give it a try? Do I sum A or do I sum B? Okay, I will let you think about it, or some of you are a little bit rusty, trying to see which are the values I'm looking for. Very good, Singy, that's correct. Anybody else still wants to try? Very good, Chloe. Anybody else still wants to give it a shot? Very good. Even better, you have given me the specific term, sum of B. Perfect. All right, I think some of you all got it ready, so let me write it down for you all. In fact, the number of data values is the total frequency. So what we are doing here, we are essentially just summing all of them up to 6, 8, 3, 1. So all you have to do, take your calculator, at the top, at the bottom, is equals to 2.75. And that's the answer which Denise gives. So good job, and I hope you understand from there. All right, now this is the mean. Now, how do we then calculate the standard deviation of the same data set? Right, so recap, the mean over here is 2.75. Again, let's follow through. This is where you realize if you were to screenshot the formula that I have shown you just now, you realize now we are looking at the bottom, the one with the f and x squared. All right, so now, how do we actually write the formula for the x square notion? Okay, now again, the standard deviation formula, this one is going to be very long, but you don't have to write it down. And again, I'm writing it down because I want you all to see. Again, we are only squaring the x. We are not squaring both. So how we write it? Frequency, there are 2 of 1s, but we are summing the squares. So it's going to be 2 times 1 squared. So on, there are 6 of 2s, but we are summing the squares, so there are 6 of 2 squares. And so on, so forth. Plus 8 of 3 squared, plus 4 of, plus 3 of 4 squared, sorry for that, plus 3 of 4 squared, and 1 of 5 squared. This whole thing over here is what we are doing when we are talking about the respective f and the respective x squared. Similarly, if I want to do it for one more, respective for f and respective for x squared. If I were to then carry on the notion, below is just going to be the frequency, what we have mentioned, 2 plus 6 plus 8 plus 3 plus 1, subtracting my mean square. All right, so I hope you have got the notion in this case of when we want to simplify and write the key values. Again, the key values are at the top. So it's going to be 171 over 20 minus the square of the mean, which is 7.5625. Again, these 3 values, very important, have to write in your working before we simplify our expressions further to get 0.99373, 3SF 0.994. All right, so that is the notion when frequency is given to you. Take note, if you with Ryan, take note, when we take note of the formula for standard deviation, recall what I said just now? We refer to the standard deviation with frequency. Did I square my frequency for this formula over here? Is there f squared? Yep, there's no f squared. So you realize over here, only x is squared. If I were to square the f, it will be written as sum of f squared and x squared. Yes, that's right. Okay, so just take note over there. That is the notion of why we don't square the f. No problem, Ryan. Glad to be of help. Because what happens? We are summing the sum of the squares. Very good questions asked ahead. We are summing the squares. Right? Yeah, right. Yes. We are summing the squares. Remember, if you talk at without frequency, we follow the same thing. The top value actually mentioned the sum of the squares. If I were to break it down to you, my top value over here, if I want to write it down, it's going to be 2 of 1s. So what do I have? 1, 1. It's going to be 6 of 2s. So it's going to be 2, 2, 2, and then you get the hang of it, 2, and so on. What we are doing over here, we are squaring each of the x values. Denise, take note. We are squaring each of the x values. 1 square, 1 square. In this case, I'll just focus on this 1 square over here. How many 1 squares do I have? 2, right? Did I square my 2 over here? No. So that's why in this case, I don't want to square the f, because the f over here is the frequency. How many f's are there? Not how many f's are there, sorry. I don't mean anything, all right? How many 1s are there? The f over here is the frequency. It is when the frequency is given. Okay, so you realize with the first formula, without the frequency given, I'll just do 1 square plus 1 square, right? But take note, I have the frequency given. So there are 2 of 1s, but I want to find out the sum of the squares of these values. So what I do 2 times how many 1s are there? 1, I do 1 square. So that's why I don't square the frequency. Okay, I hope this is a little bit clearer. If it's not, there's a Q&A. I'll enforce this concept a little bit further. Okay, but do you get understanding here? Okay, no problem. But if you are still not clear, just let me know, all right? Okay, no worries. I'll explain it to you further later, to get the understanding. Now, again, with the calculator for without frequency, with frequency, again, there's a calculator notion. Again, let's start with sharp. Since we start with sharp first, we start with sharp. So again, first things first, the analogy stays the same way. We switch to stats mode. So first up, click the mode. Okay, go to mode 1 and 0. Okay, then you realize you go to stats. First, just key in the normal data values. What happens? The data values are already given. In this case, 1, 2, 3, 4, 5. Just key in them first. The frequency will come in later. Okay? So, just key in 1, and plus 2, and plus so on and so forth. Okay? Just let the calculator do the... Let's link the video to the talking 4 and 5. Okay, now then you realize, how do I key in the frequency there? That is where you then toggle the arrows. Okay? You see x1. x1 means what? The first x value you see. If in this case, the table is 1. N1 refers to the frequency relative to the value that you saw just now. So x1 is 1, N1. There are 6 of them, if I recall. So you just key in, or is it 5? Or 2, sorry, 2. And then you realize how you change the frequency? You must click the button here. This is to say I am inputting the value now. Please press me. So therefore, and then you carry on. 2, 6, and then you carry on. 3 with the 8, so we call the same values. 4, 3, and then 5 with 1. 1, there's no need to change. After that, you solve it with, again, alpha, go to the respective values, mean, 2.75. Again, sum of the squares, what we've calculated, 171. And lastly, my mean, my data values, there are 20 values, which we have summed them. Again, you can check them with the standard deviation. Okay, so this is again the rough hang of it. Next one, for Casio, similar notion. First, you set to stats mode. For Casio, it's a little bit easier because you recall you have that table. You can just alter the table of values from there. What happens? You set to stats mode again, shift, then press the menu button, mention statistics on the frequency. Otherwise, you cannot key in. Otherwise, you key in the data values, click the menu button, go to statistics, and one variable, take note, is one variable over here. Don't key in the rest. And after that, you just key in the values with the arrow keys. So 1, 2, 3, 4, 5, just key in normally. Yes, always on the frequency because just to check also, it's to double check. Because you don't want to off the frequency and then you forget, how do I toggle again? So always on the frequency to make it a good habit. No problem, all right? So once you key in this, again, options, one variable count, so button number 2, I hesitated a bit there, sorry, and all your values are there. All right? Mean, sum of squares, standard deviation. Okay, ignore the sigma square. I only want you all to focus on this one. Sorry, this is a bit too thick. Okay, can I make this thinner? Yes, I do. Okay, so sorry for talking to myself. It's a bit weird. I want you all to focus on this one. Just the 0.993. Okay, focus on that value. All right. Now, with this notion, I hope it's a little bit clearer with frequency. Let's try again with bubble question. Find the mean of the given data set. Same thing, give it a shot. You can use your calculator, or if you want, you can write it out and calculate the top and the bottom with the calculator at your own. 1 minute, launching the bubble launcher in 3, 2, 1, let's go. Okay, take note. What is the frequency over here? What do we sum? What do we sum? What's the frequency over here? What is my mean? What do we multiply? Okay, last 30 seconds. Very good. Okay, some of you, I think a little mistakes over there. Okay, so just 20 more seconds. Give it a try. Last 15 seconds per se. Counting down to my last 10. Last 5. Okay, let me see the responses. All right, most of you all got it down. Again, it's just a recap over here, what I do. Multiply with the frequency, 5 times with the frequency, 10 times with the frequency, and 15 times with the frequency. All this is over 4 plus 12 plus 8 plus 6. Again, calculator at the top, calculator at the bottom. You will get this. All right, this is the notion over here. Or you realize you will get 7.66667. That's the correct answer as well. Okay, now calculate the mean already. Again, I believe you know what's coming up next. Standard deviation. So standard deviation, I'll give you all the mean. Let's try it out. Launching the bubble launcher in 3, 2, 1, let's go. Again, you can write SD or sigma of X. Awesome, you guys are doing good. Perfect, perfect. So let me just prepare first because it's going to be quite a bit to write. All right, doing so well, doing so good. Okay, again, there's a fraction over here that we need to write, minus something. Okay, 1 minute more. I see you guys are doing very well. Counting down to my last 15 seconds. Very good. My last 40. Counting down to my last 30 seconds. Okay, 20 seconds. For those of you to try, give it a shot. There's still some more time. Counting down to my last 8. Last 5, 4, 3, 2, 1. Okay, I think some of you just pressed the button in a rush, so let me go through. First part, sum of the frequencies. Take note, we don't square the frequency, we square the x value. So it's going to be 4 times 0. Just for understanding, don't worry, you don't know how the working. Plus 12 times 5 square, plus 8 times 10 square, plus 6 times 15 square. Okay, over, below we sum the bottom row. 4 times 12 times 8 plus 12 plus 8 plus 6 minus 7, 2 over 3 square. Again, the key values to write in your working, it's going to be 2450, top value 30 minus 58 point, in this case 7777. Truncate if you need, if you don't want to write the fraction. In this case, just write these three values over here. 2450 30, and the square of the mean. After that, click your calculator, punch in, or take note, don't key in the wrong value. 47842 round off to 3SF, 478 in 3SF, and henceforth 2 is my answer. Alright, so I hope with group data is a little bit, with ungrouped data, sorry, it's a little bit clearer on how you calculate it. And now we transit to group data with a slip of my tongue just now. So we realize group data, we cannot get an actual value because we don't know what value we are taking. So we realize for questions, that's why I emphasize on finding an estimation. Okay, now for frequency, you realize the formula stays the same, but the way we do it is the same. What value do I use for the x? So let's say example, let me give one specific one. 11 to 15, what value do I use over here? Write your responses, what value do I use over here? Okay, I'll give you some time, or the hint over here is, there's a particular way. You need to find something in a particular interval. What is that particular value we're talking about? Very good, Denise, you have gotten it. Anybody else wants to give it a try? What is the value I'm looking for the interval? No worries, later on I will show you after the lesson. Will that be okay? Don't worry. Don't worry, it's okay. Later we all try, alright? But okay. 15. Okay, that is okay for Chen Chen. That is actually not correct because you are taking a difference. I want the specific value that holds. So what we actually do is, okay, we actually do this. We take the middle value, in this case 13. So 11 plus 13, 15 divided by 2. We take the average. In this case over here, 18, 23, 28. Now, why the middle? We don't know what the spread of the data is. There may be more 11s, more 15, we don't know. So to make ourselves safe, we take the middle to ensure that it is roughly not too far from the actual standard deviation we're looking at. Okay, and how do we do this? Again, frequency times x value, frequency times x value, frequency times x value, frequency times x value, and we actually just sum the frequency. 3 plus 6 plus 9 plus 2. 410 over 20, which is 20.5. Okay, so this is the mean, how we calculate. Again, the only difference for group data is we need to find the midpoint of each interval. But that's a good try, Chen Zheng. Okay, understand why you all take the difference. We understand why you take the difference as well, but mainly over here, the midpoint is actually more important. Alright, I hope this is more clear. Okay, so right now, we move on to standard deviation. Similar notion over here, standard deviation, how to find. Again, this is going to be very long, so I'll just write it out for you all. Standard deviation, again, we take the middle data, 13, 16, sorry, not 16, 18, sorry for that, 18, 23, and 28. So what we do, again, we sum only the x value, we square only the x value. So it's going to be 13 squared times 3 plus 18 squared. So I'm effectively just summing or squaring my x values to be exact. 23 squared times 9 plus 28 squared times 2 over my total frequency. Again, 3, 6, 9, 2. Okay, sorry for that. My square doesn't look good. Minus 20.5 squared. Again, you don't have to write this. The more important thing to write is my three values over here, which is in this case 878 over 80 over 20 minus 20.5. Again, the three values they want to see is actually this one, and this one over here. Simplifying it further, I'm going to get 4.3301, 3SF 4.33. Okay, so you realize we still need to understand, because let's say if you don't understand the frequency devaluation, you can actually still derive based on the formula, which is what I've done. So you can do this at the calculator, do this at the calculator, do this at the calculator, group them together, and then we solve them. Alright? I hope this is a little bit clearer, because it's just taking the middle data, like the middle data of each frequency, not frequency, x value. Okay, so what not more to try than with a bubble question. So let's give it a shot. 1 minute, 3, 2, 1, let's go. Again, how do we calculate the x bar? Very good. X bar over here. Okay, if you have the calculator, you realize you can do it faster, but it's okay if you don't have. It's fine. Main thing is you can also do it without knowing the shortcut. So what is the, I think you all realize that the bottom is this ready. I'll just write this down, which in fact the bottom will give you 30. But what is the middle value? What is the value that I take in the interval? It's a slip of my tongue, but I think you guys got it already. Last 20 seconds. Give it a shot. Almost there. Okay, so last 10 seconds. So I hope you all realize, if you all remember, we take the middle. Then last 5 seconds. Let's see how many of you are doing it. Right. Not too bad. Majority of you got it, but I'll still go through it. So over here, I'm doing 3 times 2. Or in fact, yeah, 3 of 2s. And 13 of 6. And 10 of 10. And 4 of 14. Simplifying that, I get 2, 4, 0. Simplifying further, I get 8. So just take note, the rest of the values you may have gotten it because you divide by the wrong frequency. Okay, now with this notion, last bubble question before we move on to the investigation. Again, going back to the data set, remember I said before. Again, the mean over here is going to be my 8, which is what we have measured before. So let's try it out. Okay, how do we solve this? All right, launching the bubble launcher in 3, 2, 1. Let's go. Again, this is going to be a long chunk of formula that we take a look at. So don't worry. Some of you all chose the option there because you forget to do something. Okay. Remember the long formula, something minus something, and after that, the key values in your working. You don't have to show it to me, but ultimately, we want to see whether you're able to. Sorry for that. Yes, give it a shot. Which one is it? Okay. Give it a shot. Now, what is the middle data? I hope you all realize it's 2, 6, 10, and 14. Then from there, how do I calculate? Based on the formula. Counting down to my last 30 seconds. Okay, so I hope you all realize already the bottom should be the sum of my frequencies. And what do we have over here? The bottom should be 30. Mean should be 8 square, so it should be 64. What should I do at the top? Last 10 seconds. Counting down to my last 5, 4, 3, 2, doing good, 1. Perfect. All right, so not too bad. Most of you attempted, but let's see how we can do this. Again, we are squaring only the x, not the frequency. And if you're using a calculator, take note, it's this icon, not the S icon. So what we do, 3 times 2 square plus 13 times 6 square plus 10 times 10 square plus 4 times 14 square. All right, from here, we solve it. We get, in this case, 2264. Simplify further, 33862. Round off 3SF, 339. Okay, so what happens? This is the notion of how we do it for standard deviation. So now let's back to the point. What can we do for standard deviation? What's the notion? Okay, just nice 2 minutes. I think I can complete this. So if you refer back to this particular data set, how do we find out in terms of standard deviation? Now, I'll leave the calculation to you all for you all to try. But if you all can realize already, based on these data values, 2 and 4, 0 and 6 over here. And let's recall from the data set that we calculated just now. Okay, the number of values is 6. The mean is going to be 3. You realize already, my values over here is going to be closer to the mean. These two values are closer to the mean as opposed to my green color values. So I hope based on this, you will realize that when I calculate my standard deviation, you can give it a try as you go along. Standard deviation of x for A, in this case, is going to be, if you were to try, 0.577 at your side. Okay. Standard deviation for B, it's going to be, in this case, 1.73 at your side. Okay. Now, what you realize the standard deviation, you realize my lower my standard deviation, which means it deviates lesser from the mean, which it sort of makes sense over here. It actually shows the closer the values are to the mean. And based on this, can anybody tell me which data set will be more consistent based on the values that we have? Very good, that's right. Anybody else wants to try? Very good, Denise. We'll give it a last shot. I think this is quite straightforward over here already. The lower the data set, we are looking at data set. In this case, A. Good job, Sinyi and Denise, because it has a lower standard deviation. So what more than to go through this and make it more understanding for you all with, in this case, try it yourself. So similar notion right now, you are given two sets of data and now in a group data form, what we went through like a few minutes ago. How do we then calculate the mean standard deviation and how do we calculate the most consistent waiting time? All right, just nice. So that's it for today. So what have we learned? The recap, not so much, but how do we make use of standard deviation to calculate for with frequency, without frequency, and with frequency, ungrouped and grouped data. And okay, there's no tip for today, but mainly take note of your calculations. And yeah, that's all for today. If there's any question and answers, I'll be staying a little longer to take note of any question and answers that you have. Otherwise, this is teacher Jason signing off, and I hope that this lesson has been. Stay safe, take care. I'll see you all next week. Bye bye.